Good morning. Next we are going to discuss about crystal systems. So we are studying about mineralogy and we have different crystal systems: isometric, tetragonal, triclinic and monoclinic. In isometric, or it is also called as cubic, here all three axes are equal in length and all are perpendicular to one another. Whereas in tetragonal, two or three axes are equal in length and all the axes are perpendicular to one another. In triclinic, the three axes are unequal in length and none is perpendicular to another. Whereas in monoclinic, all the three axes are unequal and two axes are perpendicular to each other. Then orthorhombic. Here all three axes are unequal in length and all are perpendicular to one another. Hexagonal, of four axes, three are of equal length and separated by equal angles and lie in the same plane, whereas the fourth axis is perpendicular to the plane of other three axes. It is hexagonal cells. They have lattice points in each of the two sides, two six-sided faces. So you have two six-sided faces, so on the top and bottom. So the top face is hexagonal, okay, whereas bottom is also hexagonal. So these hexagonal cells, they have lattice points in each of the two-sided faces. Then rhombohedral or trigonal, here all three axes are of equal length and none of the axes is perpendicular to another. But the crystal faces all have the same size and shape. So these different crystal systems we need to study. Then monoclinic system means crystals in the system are referred to the three axes of unequal lengths like A, B, C, of which A is perpendicular to B and C, but B and C are not perpendicular to each other. So we have already discussed about crystal system, isometric, tetragonal, triclinic and monoclinic. So that monoclinic system, the explanation is given in this slide. Now first mineral we are going to study is quartz. It is SiO2. So this is a photograph of the SiO2. Now the important properties are, mainly the composition, it is SiO2 or silicon oxide of silica, silicon dioxide, and it is having it belongs to silicate group, and the crystal system is trigonal or rhombohedral. So you may be remembering what is trigonal. Trigonal means what? All the three axes are of equal length and none of the axes is perpendicular to another. But the crystal faces all have the same size and shape. Here cleavage is absent and the fracture is conchoidal. So fracture is conchoidal means you might have learnt about you may be remembering what is conchoidal fracture. So one important property of this is this conchoidal fracture, that is the broken surface of the mineral shows concentric rings or concavities, and we have when we learnt about fracture we have discussed about conchoidal fracture. If the fracture is not that deep, okay, if it is very feeble, we call it a subconchoidal, and we have there we have discussed about the example for conchoidal fracture as silica or SiO2. Okay, so similarly, so same thing here we are repeating. Then it is the vitreous. The type of luster exhibited is vitreous, and it is having hardness in more scale of hardness. The value is 7. Specific gravity is in the range of 2.65 to 2.6. It is white in color, and also the form is elongated. We have learned about different types of form in the previous video. So it shows elongated form. And the uses of quartz. It is normally used for glass making, abrasive, foundry sand, hydraulic fracturing, proponent, and also in gemstones. So all the silicates, they are simple or complex repetition of fundamental SiO2, silicon, oxygen. It's a tetrahedron, and SiO4 minus, that is the chemical composition. And the most common silicate minerals are made of chiefly of either sodium, potassium, aluminum, calcium, magnesium, iron, lithium, silicon or an oxygen. Then another variety of quartz is the amethyst quartz. Amethyst is actually purple crystalline quartz. So earlier we have told that the color is white, but now purple crystalline quartz, that we call as, it's a variety that is called amethyst. When transparent and of high quality, this is normally used as a gemstone. Okay, this is a photograph which shows the conchoidal fracture in quartz. Again, in this photo also, I think this is very clear. Then next type of mineral we are going to study is orthoclase. Okay, so orthoclase is actually it's a feldspar. It belongs to feldspar group. It's a feldspar mineral. The chemical composition is KAlSi3O8. Okay, it's monoclinic. So monoclinic means all the three axes are of unequal length and two axes are perpendicular to each other. The cleavage is perfect in two directions and it is intersecting at 90 degrees. It is available in a variety of colors like white, grey, pink, reddish, yellow, green, colorless, transparent white variety of orthoclase is called as adularia. Then luster is vitreous. It is having pearly type of luster on cleavage faces, otherwise it is vitreous, and hardness is 6 to 6.5 on Mohs scale of hardness. Specific gravity is 2.56 to 2.58. The streak means what? If you take some powder from the mineral and if you put it on a streak plate, the kind of color you observe is white, and its form is tabular, and it is normally used for the production of glass, tiles, then dinnerware, then bathroom fixtures, ceramics, etc. It is also used as an abrasive in scoring powder and polishing compounds. It is also cut as or used as a gemstone in jewelry making. Then this orthoclase is most widely known as pink feldspar and is found in many granites. And this regarding the occurrence of orthoclase, most of the orthoclase forms during the crystallization of magma into intrusive igneous rocks like granite, granodiorite, diorite and syenite. Significant amounts of orthoclase are also found in extrusive igneous rocks like rhyolite and andesite. Igneous rocks contain crystals due to the process of cooling of magma. Intrusive, they are formed below the earth, and extrusive are formed above the earth. So in igneous rocks, that is due to the crystallization of magma into igneous rocks, during that process we can find this orthoclase. Large crystals of orthoclase are known as pegmatite. Okay. Then during physical weathering, grains of orthoclase are incorporated into sediments and sedimentary rocks, and like sandstone, conglomerate and siltstone, and is also a significant constituent of metamorphic rocks like gneiss and schist. Chemical weathering alters orthoclase into clay minerals like kaolin, and this particular reaction we have already discussed in chemical weathering, how the orthoclase is converted into kaolinite, that is a clay mineral. Then next, third mineral is plagioclase. It is also the name of a group of feldspar minerals, and it forms a solid solution series ranging from pure albite to anorthite. So minerals in this series, they are homogeneous mixture of this albite and anorthite. Okay, albite is sodium aluminosilicate, that is albite is NaAlSi3O8. So AlSi3O8. So we know in the previous discussions we have discussed about orthoclase. Okay, orthoclase is it's also a feldspar mineral. We have learnt the chemical composition of orthoclase is KAlSi3O8. Okay. So whereas that of plagioclase is, instead of that potassium, if sodium comes, it becomes NaAlSi3O8. So that is pure albite. Then instead of potassium, if calcium is occupying that space, it becomes KAl2Si2O8. Okay, so instead of sodium, calcium is occupying. Okay, and the aluminosilicate equation changes to Al2Si2O8. So that is anorthite. So if you are asked to write the chemical composition of plagioclase, you have to write that of albite and anorthite. So it is albite is NaAlSi3O8 and anorthite is CaAl2Si2O8. Okay, so coming to the properties of plagioclase, here also it is a composition we have already discussed. NaAlSi3O8, that is albite, and CaAl2Si2O8 is anorthite. Okay. Then it is triclinic, and triclinic, what is triclinic you already know. It is the three axes are unequal in length and none is perpendicular to another. Okay. And the cleavage is perfect in two directions that intersect at 90 degree. Color is usually white or grey. So here you can see the photo. Also it is colorless, yellow, orange, pink, red, brown, black, blue, green, etc. are also available. Luster is vitreous, pearly on some cleavage faces. Hardness is 6 to 6.5, specific gravity 2.6 to 2.8, and the streak is white, and it is also used as an important component of many building stones, and also they are used for jewelry making. Next important mineral is biotite. It is named, this name is used for a large group of black mica. So mainly it is black mica. Okay, they are commonly found in igneous and metamorphic rocks. So here the chemical composition is KMgFe thrice AlSi3O10 FOH twice. Monoclinic crystal system, basal and perfect cleavage. Fracture is absent. Color black, dark green and dark brown. Luster is vitreous. Hardness 2.5 to 3. Specific gravity 2.7 to 3.4. And the streak is white to grey. Flakes are often produced, and this is having very little industrial use. Next interesting type of mineral is muscovite. It is most common mineral of the mica family. It is an important rock forming mineral present in igneous, metamorphic and sedimentary rocks. This muscovite, as you can see here, it has a foliated form. Okay, in the photograph you can see it is foliated. Okay, the composition is KAl2Si3AlO10OH twice. Monoclinic crystal system, cleavage is perfect. Color often black, brown or silver. When it is split into thin sheets, then it is colorless. Sometimes a tint of brown, yellow, green or rose color is also shown. The luster is pearly to vitreous, and hardness is 2.5 to 3, specific gravity 2.8 to 2.9. Streak is white, and it often sheds tiny flakes and is used in manufacturing of paint, joint compound, plastic, rubber, asphalt, roofing, cosmetics, drilling, mud, etc. Okay. Next important mineral is hornblende. It is the name used for a number of dark colored amphibole minerals. So it belongs to the amphibole group, that are compositional variants which are having similar physical property. So what is this amphibole? It's actually metasilicate. Metasilicate means silicon is to oxygen, the ratio is 4:11. Si is to O ratio 4:11. The metallic ions normally present in amphibole groups are calcium, magnesium, iron and also manganese, sodium, potassium, hydrogen, etc. The presence of OH may be replaced by fluorine or chlorine, and that is also another important speciality of this particular amphibole group. Then this amphibole group rocks or amphibolite is a type of coarse-grained metamorphic rock. Okay, and that is composed mainly of green, brown or black amphibole minerals, and also it contains plagioclase feldspar. Amphibolite is a rock of convergent plane boundaries where heat and pressure cause regional metamorphism. Okay, like when the two plates we have discussed about plate tectonics and how the plates converge and how they travel in the rate of 15 centimeter per year and all the rate and all we have learned. So when they converge, there the heat and pressure will be very high, and that cause regional metamorphism, and those are the locations where you can find this amphibolite rock, and it can be produced through the metamorphism of mafic igneous rocks like basalt, or metamorphism of clay rich sedimentary rocks like marl, etc. Okay. Then the properties of hornblende, the chemical composition CaNa3 Ca and Na 2 to 3 MgFeAl5 AlSi8 O22 OHF2. Monoclinic system, two directions intersecting at the cleavage in two directions, and it is intersecting at 124 degree and 56 degrees. The color is usually black, dark green, brown, and the lustrous vitreous structure or form is elongated, and the hardness is on the Mohs scale of hardness 5 to 6, specific gravity 2.9 to 3.5, streak white, colorless. It is brittle and often it leaves cleavage debris behind instead of a streak. So it is actually if when you try to scratch it, it breaks because it is very brittle, and the after cleavage debris, that is what you get instead of the streak, and this is also having very little industrial use. Next is augite. It is a rock forming mineral that commonly occurs in mafic and intermediate igneous rocks like basalt, gabbro, andesite and diorite. It is also obtained from intrusive igneous rocks made of magnesium and ferric. Mafic means magnesium and ferric. Okay, so this is actually a photograph of augite. It's also the composition is complex silicate. It has calcium, sodium, magnesium, iron, aluminium, SiAl2O6, monoclinic crystal system. Cleavage prismatic in two directions, and it intersects at slightly less than 90 degree. Two directions intersecting at 124 and 56 degree like that of the previous. Color is dark green, black, brown, vitreous on cleavage and crystal faces, dull on the other surface. The hardness is 5.5 to 6, specific gravity 3.2 to 3.6. Streak is white to grey to very pale green color. Okay, so augite a green, pale green streak is there. Then it is brittle because as you can see the hardness value is less. It is brittle, it is breaking into fragments, and when you rub the debris with the finger, you will get a gritty type of feel, and the fine white powder will be present. It also has no much of significant commercial use. Next, eighth mineral is hypasthene. Hypasthene belongs to pyroxene group. It is the name of a group of dark colored rock forming minerals in igneous and metamorphic rocks, and they form under conditions of high temperature and high pressure. Pyroxene minerals are normally single chain silicates. They have silica tetrahedra as their basic structural unit, and each tetrahedra of silica consists of 4 oxygen ions that surround a single small silicon ion in the center. Okay. So silica tetrahedra are arranged in long single chains. Adjacent tetrahedra in the chain share a single oxygen atom at their connection point. So this is how a single chain silicate looks like. And then pyroxene, the general composition of pyroxene is XYZ2O6. So X can be any of these mineral, again Y can be like magnesium ion, etc. and Z can be silica, alumina, or a combination of both. So a wide range of cation substitutions can also occur in this. Then pyroxene minerals crystallize in both the monoclinic and orthorhombic crystal systems. The monoclinic varieties of pyroxenes are called as clinopyroxenes, and the orthorhombic varieties of pyroxenes are called as orthopyroxenes. So regarding the property of hypasthene, orthopyroxene, MgFeSi3, SiO3, orthorhombic, perfect cleavage in one direction. Color is usually dark green to dark brown or black. It is having vitreous to dull luster, and the hardness is 5 to 6. Specific gravity ranges from 3 to 4. The streak is white, and it has few, some of them are used as gem minerals. Then the ninth mineral is calcite. Okay, so calcite is it's actually a rock forming mineral. The chemical formula is calcium carbonate. Okay, it is extremely common and found in igneous, metamorphic and sedimentary rocks. We know it is the principal constituent of limestone and marble, and it serves as one of the largest carbon repositories in our planet. Okay, so you can see the yeah, so these are all the different forms of calcite, limestone, cleavage. Then this is the cleavage you can see here. Then in the form of pink marble, and also calcite is used as like in the form of white marble. So it is calcium carbonate, trigonal crystal system. Cleavage is perfect, rhombohedral, 3 directions, usually white, but also colorless gray, red, green, blue, yellow, brown, orange. Vitreous luster, hardness is 3, specific gravity 2.7, streak is white, and it uses acid neutralization, a low hardness abrasive, soil conditioner. It is used as a soil conditioner, and also this is heated for the production of lime. So we know that calcium carbonate is heated to redness, and that is called as carbonation. Okay, it is calcination. It is called as calcination, and that is how we produce lime or calcium oxide. Now the 10th mineral is gypsum. It's an evaporite mineral, most commonly found in layered sedimentary deposits in association with halite, anhydrite, sulfur, calcite and dolomite. Gypsum, CaSO4.2H2O, is very similar to CaSO4. It is CaSO4 is calcium sulfate without any water, that is anhydrite. Okay, when 2H2O is also added, that is when the hydrous variety we call as gypsum. The chemical difference is that gypsum contains 2 waters, and anhydrated without water. Okay, so gypsum is it's a most common sulfate mineral. Evaporate means what? It's a water soluble sedimentary mineral deposit, and that is formed as a result of concentration and crystallization by evaporation from an aqueous solution. So aqueous solution evaporates and crystallizes, and that is how it is formed. Okay, so here you can see the photograph of gypsum. So here it is also, the composition is CaSO4.2H2O, that is sulfate, hydrous calcium sulfate. It belongs to the sulfate group. Crystal system is monoclinic. Cleavage is perfect. You can see the perfect cleavage is shown here. Then color is you can see clear color. There is transparent white, grey, or white, yellow color, or red, brown color, etc. Then luster is vitreous, silky and sugary type of luster is also shown, like you see the sugar, grains of sugar. Hardness is 2, specific gravity 2.3, streak is white, and it's usually used to manufacture dry wall. Then plaster. Okay, then an agricultural soil treatment we use gypsum. Okay. So thank you.